Thank you guys all for attending. It's nice to see everyone here at ONUG for the AI Networking Summit. My name is Erik Rudin. I'm VP of Strategy here at cPacket. So today we're going to talk about unified network observability and all the different elements around your environment and workflows. So quick introduction to the world of AI-based observability, right? We believe one thing here at cPacket, and that is the best data wins. But also, with the advent of AI, it's the insights that you can glean from that data that become essential for our enterprise customers. So we're going to walk through what that looks like. So today we're here at the event. We've talked to a lot of customers already. We're hearing a lot of problems with growing complexity with the network, workloads being distributed across multiple locations, including the hybrid cloud. They might have complex networks, they might have air-gapped networks, and they need to be able to observe those networks in order to provide resiliency and compliance and efficiency across all of the different operations. And a lot of these are running mission-critical applications. So to address some of this complexity, we're taking a different approach, a new approach. We also know that customers can use packet-based insights to drive both NetOps and SecOps type workflows. And so we're going to get through some nuances of that. And that is really tough because we know that a lot of our customers today serve regulatory environments. They have to have proof, they have to have evidence, and we get that evidence from the packet-based data. And lastly, and this is just a generational thing that's happening, is that we're seeing a lot of people that understand packet-based insights either move to different teams or retire. And so that's putting some stress on how does that tribal knowledge be shared across different groups, particularly if they know how the network's deployed or how the network operates, right? So a little just quick history about cPacket, if you haven't heard the brand before, but we started out as a fabless semiconductor company. So we actually build an ASIC, and we've built additional chips into our packet-based acquisition layer, which is a packet broker. And we use FPGAs on our higher performance boxes, and we OEM our NVIDIA switches at our aggregation layer. So that gives us access to a lot of different packet data feeds up to 400 gig. We also added and acquired a packet capture technology that is one of the most highest performant in the industry, up to 200 gig line rate for both capturing the packet, writing to disk, indexing, and then retrieving that information. We've extended that into the cloud, so we have all of those elements built into virtual instances that can be deployed in your tenant that will allow you to capture either VTAPs or load balance acquisition, so that we can pull packet insights into our broader framework using all the different parts of the network. And lastly, we're here to really discuss how AI is changing that game. AI is really elevating this space because we're able to do a lot more with the metadata that we provide, and we're going to go through a couple of use cases in this conversation today. So the first thing that happens when you deal with packets is you deal with data, large volumes of data. Now, we look at trillions of packets, and I'll say our customers look at trillions of packets today. They're working with very, very complex applications. A lot of our customers are in the financial services sector. We have a lot of customers that are on Wall Street, and they're building and designing very complex networks that have mission-critical applications like market data feeds. Those are the high-performance applications that are sending tons and tons of data. What we do is we capture that data, and then we start the observability journey by doing session-based metrics. And so instead of having so much packets, now we have so many sessions. But what we do is we further use AI technologies, other types of machine learning, and other types of baselining, so that we're getting further and further deeper into the insight that we can glean from those session-based insights, right? So that's at the top of the triangle. And we have to do that across the entire state, right? So if you have an edge network, if you have a core data center, if you're a hospital and you have multiple data centers, and you have to look at the traffic replicating across them. If you're a trading company and you have multiple exchanges, different segments, we can observe those different links. Also, we talked about the cloud. But what's really important is that you have a single vendor that you can work with to build trust on how you're going to look at all of that different traffic. And so a lot of times our customers have a single vendor for packet brokering and packet acquisition. They have a different vendor for packet capture. Then they have another vendor that's doing the analytics. Well, cPacket is all of that in one. And now we've added in all kinds of AI technology in order to leverage those packet-based insights. So folks that we talk to, we have to take everybody on a journey, right? When we say journey, we mean you don't just turn on AI and it just works immediately, right? You have to actually define that. And the way we do that is we look at use cases. We talk to our customers about the environments that they have, the applications that they're running, the security requirements that they have, the compliance requirements, and we start this journey. It starts on the left. So the packets are the source of truth, which means we have to catch as many packets or all of the packets, and we have different ways of doing that. In the FPGA switch that we have, we can collect all of that data at line rate, which means the actual packet acquisition is not dropping the packet. That's really essential. It's part of this journey to get to the right insight, because if you have all the packets, then you can have a better, more accurate insight. But really the magic happens at the enrichment layer. That's where we start adding other types of metadata that we are able to do at scale. So if typically you would do this with a network engineer, where you have to sit there and say, okay, where do I need to run a PCAP? What do I have all the packets that I need in order to do my assessment? Well, now you can use machines to do that. But more importantly is we're using the metadata to streamline that process. And that is where there's a lot of magic. But once we have all of this rich metadata and metrics and data pipelines, we now can start driving machine-based insights. So that could be anomalies. Are we having exfiltration on my network? Are packets leaving my network, right? Do I have east-west movement? Could that be from a bot? Could that be unintended? Is that an internal attack? Is that a performance that I expected? Is that something that's unexpected? That's where we get insights. But it's not until we integrate that to your workflow with MCPs that you start to see the outcomes. So this is some of the metadata that we get. So if you think about routing loops, this is a common use case for customers. We can build that off of the tables that we have inside of our C-store, which is our data capture. And then we're rolling that up into different analytics on time. So we can do nanosecond time stamping on every packet on our higher end box. So that can give us very intricate telemetry on latency. And then we can also look at things like drop packets. We can look at things like retransmits. So we basically start to identify where and when in the network, and then specifically what might be causing the root cause. When we layer an LLM over top, we get even more data, and we'll walk you through a use case here in a second. So at cPacket, we like to say, how would you like your observability? Would you like to get really detailed into the individual port? Would you like to have a Grafana dashboard? So we have a native Grafana dashboard built in. So if you wanted to build an analytic dashboard on HIPAA, for example, here are the biggest controls that we need to do. We can pull those insights into a dashboard. We can do that unified across different data sets, all within Grafana. And then also we have a series of MCPs that now you can use an LLM, and we allow you to bring your own LLM in your own tenant. And that's really important for highly regulated environments that have that requirement that they have to work within or behind their firewall. So we are not dependent on the cloud in order to do the LLM and the MCPs. We just allow you to bring whatever you want, connect in, and we can start doing that. And then we have a lot of customers that use data lakes and extract the data. One other capability that we really are proud of is the fact that we have an open architecture. So we can integrate with a lot of different factors on the front end, how we query the data. We have a partnership I mentioned with NVIDIA. And then we have an entire ecosystem that'll do things like CVE and threat assessment based on the packet feeds. And so we have a lot of use cases, particularly running on-prem in the cloud. And then lastly, on the types of workflows you might use. You might be using ServiceNow or Selector for running AIOps workflows. They can connect into our MCPs and start aggregating that data within the network and security stovepipe. So this is really the opportunity to collaborate. I'm going through a lot of information fairly quickly. It's a short 10-minute session here, but the idea is we need to talk about your problems, your use cases, the things that are keeping you up at night. Because if we can reduce the time to triage or run proactive workflows across these different use cases in these different areas, depending on your vertical, then we have a lot that we can work together on. So this is my one demo. It's kind of just a quick walkthrough just to give you an idea. So a lot of organizations in New York run market data feeds like Bloomberg. These are multicast feeds, they're UDP packets. They're coming at you at really high speed, and they have SLAs, SLOs that they need to be able to capture those insights. If there's any lost packets, if there's latency, if a network segment is creating problems, they need to quickly triage that and identify where that problem might be, and they need to get to resolution, because if not, they pay a penalty to their customers, or because they know that the customer might miss a trade. And so they need to provide that insight. So we take all the things we talked about, we integrate that in together, and then we walk them through a workflow. We say, okay, let's go look for things like message drops. Let's go look at sequence errors. And so all of these things you can do today manually with a human that understands networking, down all the way into the resets and then the variations. And so we can start building all of these insights into a unified view of what might be the root cause, right? Or we could throw an LLM over top and have that inspection be done by a bot or an agent. And so here would be a baseline. and then you start seeing an issue detected, and it'll actually surface that up. It'll show you the total scope and context of that problem. It'll then, once you human in the loop goes and makes the change, because we're observing, we're not making changes, and then that LLM will actually see the change, even roll up an SLA metric based on all the data that it gets from the different things, and then boom, you get your ongoing validation. So as a wrap up, just want to say thank you for your time. We believe that unified observability is key. Packets are the source of truth. Let's work together with AI together against this data set to drive insights that matter. And certainly let's build for what's next. So thank you again. Appreciate your time. If you have any questions, we're over there in the corner. We have a booth. We have staff. We'd love to just talk about your different use cases and different environments. Thank you so much for your time.